4. Now, we already knew that that was the y-intercept because of the way I introduced it. But how do you think we can find the x-intercept using that same logic? Yeah, look, if you're on anywhere on this line, right, if you're anywhere on the x-axis, your y value must be 0. So what I'm going to do to find the x-intercept is I'm going to replace x with 0 and then solve, y with 0, and solve for x. These two are opposites. If you want to know the y-intercept, you let x be 0, that'll give you your y. If you want to know the x-intercept, you replace y with 0 and solve for x. So let's do that in this equation. I'm going to replace y with 0, which means that the left side of that equation is 0. The right side is 3/2 x plus 4. And I would trust that all of you could solve that linear equation. All right, what would we do first? Subtract 4 on both sides. We're trying to isolate x. And then, at this point, divide by 3/2, or my preference would be to multiply by the reciprocal. I would multiply both sides by 2/3. That's what I would choose. And I'd rewrite -4 as -4/1. And this is multiplication here. You understand what I'm doing? I prefer that because this just kind of goes away and I'm done. I have an x on the right, and then on the left side I just multiply straight across. So what would you get? -8 on top, 3 on the bottom, so -8/3. So x is -8/3. So I'm ready to answer the question. What's the x-intercept? As a point, -8/3 and 0, because, well, y is always going to be 0 when you're looking at the x-intercept. And that's it. That's the basic idea. That's the type of thing that I would ask you to do on the test. I give you some equation. I ask you to put it in slope-intercept form. I ask you to sketch it. I ask you to tell me what the y and the x-intercepts are written as points. Think you can handle that? I think the homework, let me see the homework. You're going to get some practice. So in the homework you have part A, it's just giving you points and you find slopes. Part B, give you equations, and what I want you to do for part B, it says put the following into slope-intercept form, find the x-intercept. I'd like for you to do what I did in class for each of these as practice, because that'll prepare you for the test. Put those in slope-intercept form, sketch them, graph them, then find your y-intercept, then find your x-intercept. Just get all that information, all right? So I'm kind of adding a few. So I'm gonna help you right now. You pick one of those. Which one of those would you like me to go through? I'll go through any of those. Which one? 1 through 5? No, I just pick one. Yes, the leftover word problems. 5? Okay, had a feeling you were going to pick 5. 1/2 x minus 2/3 y equals y. Why? All right. You have to start by solving for y, right? Isolating y, getting y by itself on one side of the equation. One could argue that it's already been taken care of, right? I mean, you could almost say, look, it's solved for y, but what's wrong with that? There's still another y on the other side. So we have to get all y's to one side. So first thing you would do, I'm looking for suggestions. What do you want to do? Multiply. I've heard multiply and divide so far. Add 2/3. 2/3 y. So look, I want to get all my y's to one side. So let's put the y's over here. I want it to go way over here. Since this is subtraction, I'm going to add. So I will add 2/3 y to this side. I will add 2/3 y to this side. So over here it goes away, and I'm left with 1/2 x equals. No big deal. That's okay. The other side, though, what you're doing is you're taking one y and you're adding to it 2/3 y. And you can't just add those yet, because this is a fraction, and this one is a fraction, but not really. It's a whole number. So to add these two together, I need to know what this is as a fraction. I need a common denominator. So how can I rewrite 1 so that it has the same denominator as 3/3? So I can replace this with 3/3. And now just add those two together. What's 3/3 plus 2/3? 5/3. So the right side should be 5/3 y. Okay. And we still don't have y solved for yet because it has a 5/3 in front of it. So what would you like? Multiply by 3/5. I'm trying to get some of y'all to buy into this reciprocal thing instead of division because it's a lot cleaner. Like that. Multiply 3/5 on both sides. That would get these 3's to cancel, those 5's to cancel. That would leave you with just the y. On the left side, what? 3/10 x. We have solved for y, haven't we? Yeah. So we will have answered part A here. This is the slope intercept form. I could write it this way also. It's the same thing. Put the y on the left. All right, let's sketch it. What's the slope of this line? 3/10. What's the y-intercept? 0, right? Do you see a number out here? Do you see like plus a number? Well, yeah, plus 0. That's what's out there, right? So the y-intercept for this line is 0. So I will start by putting a point on the y-axis at 0, which is here. And from that point, I will rise by 3. What if that was negative 3? I go down 3, right? Okay. So I rise by 3, 1, 2, 3, there's 3. And then from there, I go to the right, to the right 10. 8, 9, 10, something like that. And then I connect these two with a straight line. And now let's get the y-intercept. What's the y-intercept written as a point? What is it? We know that the x is always 0, right? The y is also 0, though. What about the x-intercept? You look at your picture. The x-intercept is the y-intercept. It's the same point, right? So you actually don't have to do any work on this one to find the x-intercept. Just look at it. So the x-intercept is the same exact point. Now, you could have verified that by actually doing it. You could have said, all right, to find the x-intercept, I replace what with 0? Y with 0. If you go into this equation right here, and you replace this with 0, and then you multiply both sides by 10/3, the reciprocal, you're going to get x is 0. All right, so that's how that would work. All right, we're almost out of time. I need to pass around the sign-in sheet. And if you could carefully, see, today is the 8th. I'll start it on this end. I have a question for you which is going to lead us into the next class. I'd like for us to briefly discuss what it means for two lines to be parallel. So can someone in like regular English explain to me, as if I was a small child, what it means for two lines to be parallel? They never cross? Y'all satisfied with that? Two lines are parallel if they never cross each other. Yes. Agree? Okay. All right, so now, I agree with that almost. Any of you ever take like an art history class? Or like an art class? Has anyone taken art yet? Like art history? You study like paintings and stuff? Okay, I think all of you are somewhat familiar with like caveman drawings, right? Like stick figures, exactly, right? Cavemen were like kindergartners when it came to drawing, right? Like they were terrible artists. compared to like what artists do now, right? Agreed? Or am I stepping into the wrong place? All right, well, what makes it so different now is that, you know, if we draw a person, someone can draw it on a flat sheet of paper and it can look like almost real. Yes? It can look almost real. So I'm going to show you something now. I'm about to draw a street, okay? I'm going to draw a street with some buildings on it. Can you please not text on your phone? I'm not done yet, please. Thank you. Okay, so here's a street. And here are some buildings. I hope it's obvious to you that I'm looking from the top down. Yes? Would you say that's a pretty good drawing? Yes? Are you impressed? All right. Okay, so it's not that great. So let me try a different way. Let me try this. Is this better? Oh, that was bad. Oops. Okay, good enough. Which one do you think came from a more advanced mind? The one on the right. Yes? Yeah. Okay, so let's take a look at what's happening here. I'm trying to draw a three-dimensional space, right, which is what we live in, on a flat sheet of paper. Very difficult to do that, because it's flat. You can't do it, right? So if we go to our Cartesian rules, two parallel lines never hit. We all agree with that? Everyone said that was good, thumbs up. I agree with you. If we are living on a flat sheet of paper, that will work. Yes, these are all parallel, right? This is parallel, these are all parallels. You see all my lines that are parallel? Yes? Okay, but to trick your eyeballs into making it look three-dimensional, I have to violate that principle. And I actually have to make all my parallel lines go to a single point. See, in the real world, we know this road never meets, right? We know that the curbs of this road don't actually hit each other. But to trick ourselves, we have to make that happen. And every edge of this building that used to be parallel, right, must also follow into that same thing. So my artists in here call this a what? Yes, this is called a vanishing point, okay? This is a vanishing point. And so what I'm trying to get you to see is that we have different forms of geometry, all right? This geometry is called Cartesian geometry, and this is the geometry that you deal all of your math in pretty much in college, and until you get more advanced into junior or senior level courses. Then you realize, well, wait a minute, there's more than just Cartesian geometry. You have this stuff called perspective geometry. And here, the rules that apply here don't apply here. So we have a whole different set of rules that we use for this. So if somebody ever asks you if two parallel lines ever intersect, maybe, could be. Depends on the geometry system you're working in. If you're Cartesian, yeah, they never hit. If you're perspective, they have to hit. So, okay. We'll pick up with parallel lines and perpendicular lines next class. I guess it's a weekend, right? So everyone have a good weekend? Oh, yeah. Okay. Do your homework. We're due for a quiz. You too. Have a good one.